Okay, hello everyone, welcome to the OneClass channel. My name is Andrew and I'm currently doing Stat Math at University of Toronto. Today we'll be going over some commonly asked math questions at both the high school and college levels. And if you need some homework help or tutoring, please check out the link in the description below. Okay, so now let's start our session for today. I'll just zoom in a bit. Okay, so the first question is asking us, let's copy down the question. Q1, we need to use integration by parts. To find the integral. To find the integral e to the exponent of root x and dx. All right. So before jumping into this question, I would like to first review the theory of integration by parts. So let's do a little review right here. So integration by parts. All right. So integration by parts is a special method of integration that is often useful when two functions are multiplied together. So let's write the keyword down. Often useful when two functions are multiplied together. Okay, and we will talk about example later. And first, let's see how it will present in mathematical symbol. So integration, integral u, v dx is equal to u times integral v dx minus integral u derivative of u v dx dx. Okay. So where u is just a function ux and v is just a function vx, and this is a derivative of function ux. Okay, and yeah, so let's try with an easy example. Let's say another color. So if we are asked what is integral x cosine x dx, let's just move this to the next page. Okay, right here. Okay, so we need to solve this by using integration by parts. So solve by using integration by parts. Okay. Okay, so the first step will be we need to choose which function for u and which function for v. Okay, so choose u and v. Okay, so in our case, we will let u is equal to x, v is equal to cosine x. Okay, so now we can see it in the format integral uv dx. So we can proceed differentiate u. Okay, so differentiate u. We will have derivative of u is equal to 1, and integrate v as v is equal to cosine x, so that will be integral cosine x dx, which is equal to sine x. Okay. Yep. So now simplify, and solve. We will have x sine x minus integral sine x dx. And we know the integral sine x will just be equal to negative cosine x. So we will have x sine x plus cosine x plus c, where c is a constant. So that's how we solve by integration by parts. So now let's go back to the question. We have, let's copy down the question. E to the exponent of root x dx. So we'll let u is equal to root x, and okay, u will be equal to 1 over 2 root x dx. Oops. So we'll have 2 times root x du will be equal to dx, and 2u du will be equal to dx. So therefore, integral eu times 2u du will be equal to 2 times u e to the exponent of u du. And we let f is equal to u, dg is equal to eu du, and g will be equal to eu. We will have integral f dg is equal to fg minus integral g df, which will give us 2 times u e to the exponent of u minus integral e to the exponent of u du, which is equal to 2 times eu u minus 1 plus c. And yeah. So since we let u is equal to root x, now we need to substitute back. Okay, so we will have 2e root x times root x minus 1 plus c. Okay, so as you can see here, we just substitute u by root x. Okay, So I think that's all we got for this question. Let's leave a comment. Solution is correct. Well done. Okay, so the second question for today. So question 2. We need to find the exact value of cosine pi over 6. Okay. So cosine pi over 6, if we want to convert it to a certain degree, we will need to use cosine pi over 6 times 36 over 2 pi. And as you can see here, the pi cancels out, so we are left with cosine 30 degrees. Okay, so in other words, cosine pi over 6 has the exact same value as cosine 30 degrees. And also in a trigonometric function, we know cosine 30 degrees is equal to root 3 over 2. Okay, so the answer should be B. Let's write the conclusion, therefore. Option B is correct. Oh, and if you're wondering why cosine 30 is root 3 over 2, we can draw a right triangle. Oops. So let's say 30, 60, and 90. And we know the ratio of its sides should be 2 and 1 and root 3. Okay, and cosine theta will be equal to adjacent over hypon. Okay, so in our case, cosine 30, the adjacent of cosine 30 would be root 3, which is right here. And the hypotenuse will be just the longest side, which is 2 right here. Therefore, we have cosine 30 as root 3 over 2. Okay? Yeah, so that will be our answer. Okay, so let's leave a comment. So solution is correct. Well done. Okay. So our next question is asking us to find how to find the integral of e to the exponent of x sine x dx. So if we write that in mathematical symbol, that will be integral ex sine x dx. Okay, so recall that if we have two functions multiplied together, we always need to think of integration by parts. Okay, so interpolation by parts. Okay, which follows the formula integral u dv is equal to uv minus integral v du. Okay, so now let's solve the question. So the first step, we need to let u will be equal to e to the exponent of x, and dv will be equal to sine x dx. Okay, therefore we can convert the original question to the form of integral u dv. Okay, and we just need to get the derivative of u. Let me write it this way. So du dx will be equal to d dx in x. Okay, and du dx will be equal to ex, and du will be equal to ex dx. Okay, and the value of v, okay, so value of v, we have integral dv, which is equal to integral sine x dx, which is from right here. So we substitute dv by sine x dx, and v will be equal to integral sine x dx, which is equal to negative cosine x plus c, where c is the constant. Okay, and so that's the second step. And our last step would be we need to substitute these values in the formula for integration by parts. So substitution. Okay, we will have integral ex sine x dx will be equal to ex times negative cosine x minus integral negative cosine x ex dx. Okay, and that will be equal to negative e to the exponent of x cosine x. We just move the negative sign out, minus negative integral ex cosine x dx. Okay, and yep, so now we only need to evaluate integral ex cosine x dx. Okay, so in other words, we need to apply the integration by parts again. So solve for, yep, so same thing, let u, let u is equal to e to the exponent of x, and dv is equal to cosine x dx, and du dv will be equal to d dx ex, and du will be equal to ex times dx. Okay, and the value of v, we will have v is equal to integral dv, which is the same thing as integral cosine x dx, which is equal to sine x plus c. Okay, and substituting this value back into our original equation, we will have substitution ex cosine x dx will be equal to ex sine x minus integral sine x times ex dx. Okay, and that will be also equal to ex sine x minus ex sine x dx. Okay, and now we're substituting this part to the equation, like our original equation. We will have integral ex sine x dx is equal to negative ex cosine x minus negative integral ex cosine x dx. Okay. And we get negative ex cosine x minus negative ex sine x plus integral ex sine x dx. Okay, and simplifying that will give us negative ex cosine x plus ex sine x minus minus integral ex sine x dx. And now let's move this part to our left hand side. So we will have 2 times integral ex sine x dx will be equal to negative ex cosine x plus ex sine x. Okay. And dividing both sides by 2, we will have integral ex sine x dx will be equal to the whole thing divided by 2. Oh, and plus c, where c is a constant. Yep, so now we can write down our conclusion. Therefore, the integral of ex sine x is negative ex cosine x over 2 plus ex sine x over 2 plus c. Yeah, so I think that's the answer for this question. So just remember, sometimes you're gonna use integration by parts twice in a single question. Oh, and don't forget to add the constant at the end when you're solving integral. Okay, so now let's leave a comment. So solution is correct. Good. Yeah, so those are all the questions for today. If you enjoyed today's Q&A and would like to be notified of when we do this next, please hit the subscribe button and notification bell below. If you'd like to submit your own questions, please read the link in the description. Remember to leave a like and a comment and share this video with your friend. This has been Andrew from OneClass. I hope to see you